Okay, so in this video, we're going to go over the two properties of tangents. One dealing with tangent line to circle theorem, and the other is the external tangent congruence theorem. I will go over the theorems, and then I will do an example or two of each of these. Okay, so looking at a tangent line to circle theorem, here is a picture that talks about what that means. Using words, it represents the idea that in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So that can be a little bit confusing. So let's look at this picture and talk about what this means in regards to this picture. So it's saying that line M is tangent to circle Q if and only if line M is perpendicular to our radius QP. And that works the other way around. So if line M is perpendicular to QP, then I know that line M is tangent to circle Q. Okay? So let's go do an example using this, and that would be looking at this problem here where it says, is ST tangent to circle P? Okay? So what we need to figure out in order to know that ST is tangent to circle P is we need to know that we have perpendicular lines or perpendicular segments. So we need to know that ST is perpendicular to the radius TP. And if we know that those are perpendicular, then we know we have a right angle. Well, let's determine if this would be this triangle that we see here. Let's determine if this triangle is a right triangle. Because if it is a right triangle, then we can definitely say that, yes, this is a right angle here, and therefore ST is tangent. Because as long as ST is perpendicular to our radius, we can say that that line is tangent to the circle. So the way that we can determine if this is a right triangle is to use Pythagorean theorem. Pythagorean theorem states that as long as a leg squared plus another leg squared equals the hypotenuse squared, then we know that the three side lengths make a right triangle. So remember that your hypotenuse is always represented with C. That would be the side opposite the right angle. So my value of C is going to be 37. And then we have our legs are the two sides that intersect to make the right angle. So one of our legs is going to be 12. The other leg is going to be 35. So I will have 12 squared plus 35 squared equals 37 squared. Then using my calculator to simplify that, I'm going to have, I know 12 squared is 144. 35 squared, whoops, that's too big. 35 squared is 1,225. Adding that to 144, I get 1,369. And then 37 squared is 1,369. So you can see that it holds true for the Pythagorean theorem. So therefore, I know that this has to be a right triangle. So this is right triangle. Yes. So therefore, we can say that, yes, ST is tangent to circle P. And the reason for that is because we know that ST is perpendicular to the radius PT. Okay? Another problem that we can use this theorem on is problem number 2. In problem number 2, it has in the diagram, point B is a point of tangency. Find the radius R of circle C. So it's telling us that B is a point of tangency. Okay. So if it's tangent, then we know that we have perpendicular lines. So I know that AB is perpendicular to the radius, therefore making a right angle there. Okay? They want us to find the length of R. Okay? So the way that we're going to do that is we're going to use Pythagorean theorem again. So whenever we go to use the Pythagorean theorem, we don't know the length of AC by its value, but we know that it is a combination of 50 and R. So that means that our hypotenuse length is going to be represented by the binomial 50 plus R. So this will be a good review of algebra. Our legs are going to be 80, and the other leg will be just R. So I have my A squared, which will be 80 squared, plus my B squared, that'll be R squared, is going to be equal to my hypotenuse squared, which is represented by 50 plus R to the second power. Okay? You can also write that as R plus 50. If you prefer that, that's fine. So 50 plus R to the second power, you cannot distribute the 2. You must write it out and either use a FOIL method, multiple distribution, or maybe an area model to multiply. So you're going to multiply the first terms. 50 times 50 would be 2,500. You're then going to multiply the outside terms. That'll give you 50R. Then you have to multiply R to everything in the second parenthesis. So those are these inside terms. That gives you another 50R. And then R times R will give you R squared. Combining my like terms, I get 2,500 plus 100R plus R squared. So simplifying over here, I'm going to go ahead and write this over here. That's 2,500 plus 100R plus R squared. I can't simplify this R squared anymore, so there's that. And then I need to do 80 squared. That's 6,400. So now all you need to do is solve for R. So when I go to solve for R, I want to try to get R all by itself. What I notice is I have a positive R squared here and a positive R squared. If I try to go to combine that, so moving this to the other side, subtracting R squared on both sides will cancel this out and cancel that out. So that's good. That leaves us with one term that has an R. So I'm going to go ahead and subtract 2,500 on both sides. So if you do 6,400 minus 2,500, you're going to get 3,900. Dividing both sides by 100, I get a value of R to be 39. So in this problem, my units of measure are 50, so I know that the radius is 39 feet. Don't forget to write complete sentences and use your units. I forgot to circle my answer on that last problem. Okay? So those are two problems that go over this first theorem. The second theorem is what we call the external tangent congruence theorem. This states that tangent segments from a common external point are congruent. So they're basically saying that if you know SR is, SR and ST are tangent, okay, then we can say that they are congruent. So SR congruent to ST. Okay, so being able to say that those are congruent, which will allow you to set them equal and possibly find more values. So let's look at an example that uses this idea here. It says RS is tangent to circle C. So that's RS. It says that, and we also know RT is tangent to circle C, right? So we know that this is a tangent and we know that this is a tangent. It says find the value of x. From that external tangent congruence theorem, because these are both tangents, we can say that they are congruent, which means that their lengths are equal. If their lengths are equal, you can set their lengths equal to one another and solve for the variable x. So subtracting 4 on both sides, dividing both sides by 3 will give you an x value of 8. So in this problem, all they've asked you to do is find the value of x, and the value of x is 8. And you could very easily check your answer by plugging it in here. If you do 3 times 8 plus 4, you can see that it does give you a value of 28, which is the same as the other tangent segment in the problem. So I hope these two examples have helped you out. Good luck with your practice on these two theorems.